So we are going to go ahead and solve the output maximization problem using Excel. We already solved the problem, and if I remember it, actually let's just go ahead and check. From our earlier calculations, we found that the optimal level of capital was 51.85 and optimal amount of labor was 58.33. Let me just go ahead and write out those maximum values. So the amount of capital and labor which maximizes output maximized when, all right, so capital is equal to, like we said, 51.85 units, and labor is 58.33. Let's see if we can have those same results. And under those circumstances, the output which is maximized turns out to be equal to 560.88. Let's see if we can get those same results using using Excel, basically. So that's our goal. Okay, let's just highlight them. There you go. So this is the output which is maximized. Let me just go ahead and yes, and these two as well. I'm just going to align them in the correct way. Yeah, there you go. And maybe I can align them left alignment. There we go. And this one as well. So I'm just playing with the format. Okay, so what I'm going to do it in two ways, and I don't want to look at some alternatives, which is and we can write out a lot of alternatives like we did in the previous cost minimization problem. I want to directly attack the problem this time, but what I will do is I will have two different solutions. So solution 1 versus solution 2, and you will see how you can add a constraint. In the previous, when we solved the cost minimization problem, it felt like we used a trick and it's not clear how the constraint was there. But here I want to clearly show the constraint. Though I would like to also continue providing the trick solution as well, Q, which is the output, right? Let's just, so this is capital, oops. Oh shoot. All right, here we go. Capital. We have labor here. Labor. So cost. And I can represent it as C. Well, I can write the actual formula, right? So it is just R times K plus W times L. This is how much you pay for all the factors of production. So here is the output. And output is given by the following formula, which is basically the function itself, 10 times, yes, K raised to the power 1/3 times L raised to the power 2/3. And let me just, go ahead and replace that with capital K. There you go. All right, so messed up again. All right, so, yeah, there you go. Okay, so let's just turn this off. Okay, how do I get, okay, there we go. All right, so let's just go ahead and write those formulas as well here. So the formula here is R, which is 9, remember, times the amount of capital plus 16, which is the price for labor, times the number of labor units. All right, so as an example, 10 units of capital and 10 units of labor will cost the company $250, and as a result, how much will be produced? Let's check. 10 times capital is raised to the 1/3 power times labor is raised to the 2/3 power. So if you were to use 10 units of capital and 10 units of labor, it would have cost the company $250. Let's put a $sign there. However, let's skip the cents. And as a result, 100 units of output is produced. So what I will do is we can just go ahead and drag it down, right? So it's pretty much, so here you can check again some hypothetical cases. I said I won't do it, but I can't resist. So for instance, here's an example. If you were to use 100 units of capital and 1 unit of labor, it would have cost this much, and as a result, the output would have been this much. Because we want to spend 1400, so maybe I want to increase this, right? So let's keep increasing until we hit 1400, right? So I think use even more labor here, even more. A little bit more maybe. There you go, too much, 31, something like that. So I still have some room to play with the I think I can use half an hour more of capital. There you go. So here is an example where we use 100.5 units of capital, 31 units of labor, total hours of labor, I should say, and hours of capital. That will cost us an overall 14, actually a little bit less than that, right? So it didn't work out like, yeah, so it will cost us roughly $1,400, and as a result, we will produce this much. But that's not the only combination of capital and labor which will cost this much, right? So for instance, if I were to, and notice that the production is 458, right? So let me just go ahead and scroll that down. Check this out. Let's have a look at an alternative here, 3. What if this one was 75, and as a result, I could have used like 20. Does that work? Maybe 21, 22. 22.2 maybe. Yeah, there you go. So here in this combination, I'm using 22.2 units of capital, 75 units of labor. The overall cost is 1,400, and production has increased. Now it's 499. It's almost 500. So the question is, what is the right combination? And the answer was this, right? So we realized that this is the right combination. Let's check. 51 point. Oh, actually, let's first extend. Actually, let me just go ahead and extend these formulas all the way, I guess. There's no harm. There you go. So if I were to use a combination of 51.85 units of capital and 58.33 units of labor, that would have cost us again $1,400. But look at the production. Production is 560. I claim this is the maximum that can happen, right? We couldn't have done better, right? So that's the optimal result. Let's see if we can have Excel do it for us, right? So let me just go ahead and provide you 2 different ways to solve this problem. So Excel 1, that's one way. One way we can model it is Excel. Oops. Oh gosh, I keep pressing the wrong button. Okay, solution. One way to do it is we can do the trick that we employed earlier. So in the following way, so let me just get rid of, well, okay, let's keep it. Because I want the cost to be exactly 1,400, what I can do is, for instance, I can express capital in terms of labor. This time, let's do switch them. So what I will do is I can move that 9K to the left-hand side. 1,400 minus 9K is equal to 16L, and further divide by 16. So L would be 1,400 minus 9K, all divided by 16. So why don't I write it in terms of L then? Open parenthesis, 1,400 minus... No, I need to write L in terms of, sorry, K in terms of L. So 1,400 minus 16L, 16 times L is this number, all divided by 9. Do you guys see that? And as a result, so regardless of what L is, if it is 0, obviously, what if it's a 1 or 2? Do you guys see, as I change the amount of L, this is automatically updated, but the cost regardless is always the same. However, the output keeps increasing, right? So I need to probably keep increasing it until when? You know, until what? So as you guys can see, output keeps increasing. I need to keep changing L, increase it until output doesn't increase anymore. Let's try 40. Oh, it keeps increasing. How about 50? It increases even more. How about 60? 60 is better. 70. Oh no, it went down. Do you guys see that output went down? So maybe 65? Oh, output went up. Okay, how about 62? Output went up further. How about 60 again? Output went up further. Okay, how about 59? Oh, so you see the game, right? As soon as I write 58, we realize that we are overshooting, and so optimal allocate. We know the optimal. So I don't want to do guess and trial, right? I want to find the L here, keep changing the L such that, well, this one I don't have to worry about the constraint anymore. It's fixed. All I need to worry is this maximizing this. So let me just put it in a random number. Okay. Wow. So oh, because this is too much. Okay. So let's start at 50, or let's say 20. Okay, there you go. All right, so what I will do is I can just go ahead and use solver again. So data solver, and our goal objective function this time is this number. I want to maximize that. Maximum is selected by changing which cells? By changing labor itself, because as soon as I change labor, this one will already be affected by it, which will affect cost. It will remain at 14, and yeah, that's the choice variable, so the control variable. And I don't have to worry about the constraint. Capital and labor are greater than or equal to 0. I don't want to change the optimization technique, and that's pretty much it. Yeah, so these are the solver parameters here, right? Okay, good. So, and I just press solve. And Excel, wow, look at that. Isn't that a beauty? These are exactly the same numbers. And look at this output, which is exactly the same as I did it while I was solving it manually. I got the same number here. So that's perfect. I really like this. An alternative way to solve this problem, Excel 2 solution, this one is without making that trick. And it is the following. So this time I'm gonna change both K and L at the same time. So here the choice variable was K. Let me highlight it. This was the choice variable. As soon as I was changing L, I should say, it automatically updates K because I inserted a formula underneath it. Do you see the formula? So the content of this cell depends on this in such a way that the combination of these two will cost us 1400. And as a result, when I was maximizing this, that's my objective function, right? As I'm maximizing that, let's use this color. All I did was to keep changing this variable, a single variable. Now I'm going to change both of them at the same time. But for that, I need to use the actual constraint, right? Again, the goal is to maximize this. And somehow this is, it seems, this is the, what do you call it? This is the politically correct way to solve this problem. All right, so with the constraint, because this is an example of a constraint optimization, let's solve it the correct way. And the correct way is the following. So that's what I want to optimize. Let's go to data ribbon again, solver. And okay, so you guys can see the parameter there. All right, let's start with the first one. So it's no longer that. So we want to optimize this cell, the content of this. I want to maximize the output, to be more exact. All right. Maximizing it by changing which cells. Now this is critical. So by changing these two now, wow, two variables at the same time. All right, but now I need to add a constraint. I want to change those two variables, capital and labor, in such a way that cost is exactly 1400. I want that the machine to recognize that, so I add that constraint. So what is the constraint? That cell reference is this number here, which has the actual formula related to cost. I want that to be exactly equal to 1400. So I want to maximize this while making sure that the combination of capital and labor that I'm using is exactly 1400. Do you guys see that? That reference is related to that cost. And I add it. Oh, sorry. I should have said okay. Okay, just say okay. Okay, cancel this. Oh, there we go. So the constraint is here. I should have pressed okay there. If I want more constraints, I can add them. Actually, there's another constraint. Both capital and labor should be greater than or equal to 0, but these are redundant. Let me just put them anyways. So capital here, I want to make it greater than or equal to 0 and say press OK. And I want also labor to be greater than or equal to 0. I want to make sure that's going to be the case. Oh, sorry. Greater or equal to 0, press OK. But the thing of the matter is those two constraints are not necessary to put, because here, look at that. Here it says make unconstrained variables non-negative. So it's already part of the problem. So either I uncheck it and add these two conditions, or if it's checked, those two conditions are irrelevant. So I can just delete those two conditions. Delete that one and delete that one. They are totally unnecessary. All right, does that make sense? But at the same time, okay, so let me explain one thing. If I'm using too much labor or too much capital, the cost will exceed 1400, and I well, okay, so if I use too much labor, then capital will fall, it has to fall below minus, but that's not allowed anyway, so I don't have to worry about it regardless. Awesome, so now that I mentioned all this, so now we can go ahead and press solve, and let's go, long behold, hold our breath. Yay, this exact same answer. So we can, the output maximization problem, we can produce as high as 560.88 units by using these certain combinations of capital and labor, which will make the cost at 1400. And that would solve pretty much this problem. A very, very neat problem. So we learned how to use a constraint optimization. Sometimes the constraints might be non-binding, right? So if you add a non-binding constraint, it won't have any effect whatsoever on the actual solution of the problem. All right, so hope you guys enjoyed it. So what we did is we found the optimal output, and the cost was 1400 if you use exactly these two combinations. There are other combinations which will keep it at 1400, but they won't produce such a high output as this one. Now you might say, wait a second, 499.83. This is very close to 500. Well, 500, but not 560. Yeah, 560 is way better than those. All right, so that's all I have for now. So I hope you guys enjoyed this one.